Welcome to Barcode Library. Here we'll show you how to use our software to read all kinds of 1D and 2D barcodes. Here we will learn how to scan, read barcode images using BarcodeLib C Barcode Reader library. Barcode Library supports QR code, data matrix, code 128, PDF 417, EA and UPC, and other 20 more barcode image recognition in Visual Studio.NET application. I've already added Barcode Library, Barcode Reader Library, DLL to the C# console project reference and installed system.drawing.common NuGet package through NuGet Package Manager. In this guide, we will try to scan and read the GS1-128 barcode text string from these image files. So let's go ahead and go to the program CS file. We start with two essential using directives at the top of the code file. The first one using BarcodeLib.BarcodeReader imports the full barcode decoding library, which provides all core classes we need, such as optimize setting, barcode, and the static read barcode scan method. Since GS1-128 is a special subset of code 128, we rely on the code 128 recognition engine built into this library. The second line using system.diagnostics loads the system debug toolset, so we can print all valid decoded barcode text to the debug output window for easy result checking during testing. Right after the namespace imports, we add consistent formatting lines to separate each independent image scan test. Multiple empty debug.writeLine statements create blank space between test results, paired with a dividing dash line and a label line to mark each scanning group. This neat layout prevents log outputs from different test images from getting mixed together. Each scanning segment is wrapped in its own pair of curly braces. This creates an isolated local scope for variables, options, and datas, so there will be no naming conflicts between the three separate scan blocks, and each test logic stays independent and easy to modify individually. Let's break down the shared workflow inside every block first. Inside each isolated scope, we initialize an optimized setting object with BarcodeReader.code128 as the target symbology. GS1-128 barcodes use the code 128 barcode structure, so locking the scanner to code 128 speeds up detection and filters out other irrelevant barcode formats. We then invoke BarcodeReader.readBarcode with the local storage path of the target image and our optimized scan settings. This method returns an array of barcode objects called datas as one image.
Here's the key unique logic for GS1-128 compared to regular code 1-8 samples we looked at before. The for each loop has an extra conditional checkif. This property verifies whether the detected code 1-8 barcode follows GS1 standard rules and carries valid GS1 application identifiers. We only print out the decoded barcode text when this condition passes, which filters out ordinary non-GS1 code 1-8 barcodes that might exist in the same image. Now let's talk about the slight differences between each test block's target image scenarios. The first code block targets a standard upright GS1-128 barcode as its comment notes. We use the standard code 1-8 scan setup plus the GS1 compatibility check to extract and print only valid GS1 formatted content. The second block works on images containing rotated GS1-128 symbols. We do not need to add any extra rotation correction settings. The scanner's native algorithm automatically detects skewed barcode bars. The same GS1 compatibility filter still applies to validate the decoded data before outputting text. The third block handles GS1-128 symbols without human-readable text labels printed below the barcode bars. The scanner only relies on the barcode's bar and space pattern for recognition, so missing text labels will not break decoding. The GS1 standard validation check remains in place to confirm valid GS1 data before logging results. All blank debug print lines and divider separators exist solely to organize debug logs visually. Separating each image scan into its own enclosed block keeps the whole script modular, letting us add, remove, or adjust single test cases without interfering with other scanning logic.
Now let's run the console application and see the scanned barcode text output. Review of the first scanned barcode image file. This image contains a standard straight GS1-128 barcode with complete standard formatting and readable text labels under the bars. We restricted the scanner to code 128 mode and added a GS1 compliance filter. The scanner quickly located the symbol. The is GS1 compatible check returned true, and the full GS1 encoded barcode text was extracted and printed without any recognition errors. Review of the second scanned barcode image file. This image stores a GS1-128 barcode placed at an inclined rotated angle. No special rotation parameters were configured, but the scanner's built-in skew detection logic aligned the barcode pattern successfully. The code confirmed the symbol matched GS1 standards through the compatibility property, then output the complete valid GS1 barcode text as expected. Review of the third scanned barcode image file. This image's GS1-128 symbol does not have auxiliary human-readable text printed below the bar lines. Since the decoder only processes the barcode's black and white module pattern, the lack of text labels had zero negative impact on scanning performance. The GS1 validation check passed normally, and the full encoded GS1 barcode text was fully retrieved and logged. All three distinct barcode image files finished scanning with complete success. Every GS1-128 symbol in each image was accurately located, passed the GS1 compatibility verification, and returned complete usable barcode text data without any missed or garbled content. Thanks for watching. Subscribe and follow Barcode Library for more barcode tutorials.